Okay, welcome to today's Training Tuesday. And thank you all for joining us today. I am Chuck Hoke. I am the product training manager here at Dayton Superior. And we are glad that you could make it for today's DBDI Threaded Splicing System Training Tuesday. Before we get to it, we have to look at a little bit of housekeeping rules here. Like everyone, as usual, all calls, everyone here on the call has been muted, and the webinar can be free either for disruptions or anything else, any other interruption. But please feel free to provide any questions you may have throughout the presentation through the formal chat section within the Zoom functionality. At the end of the presentation, we will have a mini question and answer session we can take care of any questions that you may have regarding the product line that we are going to be talking about today. Each of these webinars, just so you know, is recorded, so it will be posted online here. Usually later on this afternoon, you'll get it. It'll be up on the DaytonSuperior.com site and or on the YouTube section. So today we're going to be talking about splicing. Now, who is Dayton Superior? Well, we are not just about splicing, but we are the leading provider of engineered solutions within the concrete construction industry for accessories, chemicals, forming. We have proven solutions for everything within, especially on the assignment side of the systems, the forming, shoring, etc. So we actually have one of the largest engineering groups available to help suit your needs for any of these topics that we are going to be talking about. Along with the largest and most experienced, talented engineering group within the marketplace, we also have a technical support team that can help provide specific solutions for your projects, whether it be chemical, accessory, splicing, any of the accessory lines, precast, etc. So we actually have that all in-house here today. And today we're going to be talking about splicing. And I am happy to say that I actually have a good friend of mine come to you and talk to you today about DBDI, and that is Matt Mahar. And Matt is one of our technical sales service representatives from our splicing team. He's actually based out of Texas. Matt is a graduate of Texas A&M, and he's been in the construction industry for over 15 years, dealing with installation and fireplaces and actually rebar in particular. So for 10 of those years, he has worked in the rebar fabrication end of the industry. And he's also been dealing with concrete accessories in his past life. So Matt is a member of CRSI and sits on the committee for the reinforcing bar fabrication for them. He also is on the splicing and anchorage committee that CRSI has, and he's also a member of ACI. So with that, Matt, I am going to turn it over to you.
Awesome. Thank you, Chuck. I appreciate it. I want to appreciate you guys for being on the call today and taking a little bit of your lunch hour or a little bit of your time to spend with us to talk through some splicing and specifically through our DBDI. I do want to give one shout out to a participant that we have. I noticed his name on there. Sean Van Rassel is one of our guys. He's on the call, just listening in. but he is our guy up in Canada for splicing, and is probably second only to Chuck in his knowledge of splicing and splicing techniques, splicing products, and information regarding it. So if you're up in Canada, he is the man to talk to. And if you're not up in Canada, you might give him a call anyway, because I call him frequently to get information and advice. So with that, we're going to talk through today our DBDI system, and we'll walk through first here just some general splicing stuff to give you guys a background and a quick informational dump of what splicing is, what mechanical couplers are, and how they differ from traditional splicing methods, the different pros and cons of that, and then we'll jump right into the DBDI system and give you guys a good overview of that. So shouldn't take too long today, but I want to make sure that we're thorough in what we do. So let me make sure I've got, did you pass over control me, Chuck?
There you go.
There we go. Perfect. Awesome. So let's jump into some splicing methods and definitions, different techniques. So the three main techniques that we're going to see are going to be welded, lap splice, or mechanical. Welded is exactly what it sounds like. You take two reinforcing bars, sit them side by side, and then with a arc weld, you're going to join those two bars together. They can be lapped, they can be butted, they can do plates or angles. It is a expensive process. It is a time-consuming process. It is a process that is, I would say, is not as frequently seen anymore, but I just 2 months ago had a set of plans come across with welded splices in it that the engineer wanted me to review. So it is rare, but it is still out there and still used. So depends on what the situation calls for. Lap splice is the most traditional splice that we're going to see. That's what everybody sees in paving, especially a lot of wall work, anywhere. It's just the overlapping of two reinforcing bars where you put them side by side, and you have pigtails or tie wire or a max tie gun or a Cody clip gun that puts your two bars together. That is dependent on the size of the bar for how long that overlap is and what you need to develop the strength of the connection. And then we have our mechanical splices. And so the mechanical splice textbook definition is the complete assembly of an end-bearing sleeve with a coupler or coupling sleeve. It has additional materials or parts to accomplish the splicing. Most common methods that you're going to see out there are going to be threaded, bolted, or grout filled. You do see less commonly the swaged option out there. There is one company in the market that uses that almost exclusively, but they've gone to some other methods as well. And so just to give you guys some visuals and a couple of more notes on those, again, for our welded, this is a picture of just doing it butt to butt, and it's done again through electric arc welding, maybe lapped, butted, or again, joined with angles or plates. Your lap splice is your traditional, it's just side by side rebar with wire holding it together. And then you have your mechanical splice that uses a separate function. So the one we're going to talk about today will be a threaded version. Most people are familiar with a bolted connection. There are also grout-filled connections that are predominantly used in the precast industry. And then again, the less commonly used swage. So again, looking at just an overview of everything here, welded splice, to walk you through it. Rebar 1, rebar 2, put an arc weld after you figured out what the development length is. That weld would actually be almost the full length of that lap to hold those bars together. This is going to be dependent on, the strength of this will be dependent on how good your welder is and on the concrete that's holding it together. So those are things to consider. Here again, a traditional lap splice held together by tie wire. You've got to figure out what the developmental length is for the lap to make sure that you're getting full capacity of the bar or as close to full capacity as you can get. Again, this is going to be highly dependent on the concrete, and it's going to be highly dependent on the installer, because you have some job sites that I've been on where they put pigtails every 3 inches. You have some that you go on where they have tie wire every 10 inches, some where they have one piece of tie wire holding bars together. It just depends on who was doing the installation that day and how many wires they felt like putting together. There's no standard holding together how many different, how much tie wire they should have at a given interval. So it's dependent on the installer, and it's dependent on the concrete for how secure this is going to be and what kind of strength it's going to give your structure. Obviously, between those two, you can have some failures because they are dependent on the installer. They're dependent on the methods that are used, and they're dependent on the concrete holding them together. So some of the issues that you'll run into are movement failures. So the picture on the left there is a column that failed because as the structure moved, the lap splices came undone and caused a catastrophic failure in the column. Some of the other issues that you run into when you're dealing with lap splicing, whether it's welded or it's traditional tie wire lap splicing, is you're going to run into congestion issues. Obviously, the picture in the middle and the picture on the right was a great day for the rebar salesman. I love those pictures in our presentation because I used to be a rebar salesman, and all I see is dollar signs because it's really, really, really great, and it's a lot of rebar. The engineer probably had a fun time designing all of it and putting it together. The installer did not have a fun time putting it all together. And the concrete guy had an even less fun time trying to get all of the concrete in there. One of the biggest issues that you'll run into with a situation like this is what we call rock pockets. That's where all of the slurry from the concrete flows through, but all of the aggregate is held up by the rebar, and you get a weaker structure because the aggregate is part of the support and everything doesn't work together. You're not getting the right blend of concrete throughout the structure. So you wind up with weak spots throughout your build, and eventually you wind up with a failure. So congestion is a big concern. It's becoming an even bigger concern as environmental factors are coming in and people are starting to look at carbon content and different stuff like that. So the answer to all of that, whether it's installer questions or concrete support questions or congestion questions, are to use a mechanical splice. Again, the complete assembly of an end-bearing sleeve coupler or coupling sleeve. Basically, what a mechanical coupler does is allows two separate bars to behave like one large bar. I always tell people, if you have a drilled pier shaft and you have two 60-foot bars and you couple them together, they will act like one very long 120-foot bar. Again, our most common methods of that are shear bolt. You have two threaded options of taper thread or parallel thread, and then grout filled and swage. So the advantages here are that they offer a precise and reliable connection. It's going to be the same connection every time. They have a much lower installation cost. They have a much more precise installation. They are stronger and more reliable than your other two forms of lap splicing. Not dependent on the concrete for load transfer. That's a big thing. All of the testing for these, or the majority of the testing for mechanical couplers, is done in a lab outside of concrete, independent of any outside forces, so that we are assured as a manufacturer, as whatever regulatory force is overseeing the project, that the mechanical couplers are going to cause the rebar to act the way the rebar should. And there's not going to be any variables to that dependent on any outside force. So as a result of that, you get a stronger connection, superior cyclic performance, and greater structural activity during seismic events is achieved. That's a really important thing as well, is the performance of mechanical couplers in seismic zones far outperforms regular lap splices or welded splice. And then this last note here is correct and not correct. So we're going to dig a little bit into current situations. So typically for the last 40-ish years, there's been type 1 and type 2 connections for mechanical couplers. And that is 125% of the yield of the bar and 100% of the tension of a bar. So that's these two definitions here. Type 1, as defined in ACI 318, is a full mechanical splice that gives you 125% tension of the bar, or I'm sorry, yield of the bar. And then type 2 gives you that same 125% of yield, but it also gives you 100% of the tensile strength of the bar. Now, why I say that this is correct and incorrect is because in the beginning of this year, ACI 318-2025 came out with S, G, and L classifications and did away with the type 1 and type 2 designations for mechanical splices. In doing so, they kind of shook up the industry a little bit. Currently, no manufacturer has any coupler that will meet a Class S splice as defined in ACI 318-25. The majority of us, including Dayton Superior, can comply with Class G, and we have several that can comply with Class L. As Chuck mentioned, I'm on the CRSI committee for anchorages and splices. That committee is actively working with ACI 318 subcommittee to address the change that was made. And in the future, I think there will be a shift back to type 1 and type 2 with the inclusion of a couple more classes, type 3 and type 4, that would incorporate some of the other types that are needed at this point to kind of update the code. But if you are an engineer that is doing everything to ACI 318-19 and previous, then you would still use type 1 and type 2. If you are designing to ACI 318-25, you would have to use Class G, L, or S. But again, nobody on the market has anything that will hit a Class S as it is currently defined in ACI 318-25. So hope that clears all of that up. If you guys have any questions about that, throw it in the chat and we'll address that at the end. Again, this is just another slide here to show how those ACI and ICC code requirements work together and what it means for the difference between a type 1 and a type 2. So you can see that on grade 615 rebar, if you're grade 60, your type 1, 125% of yield is 75,000 PSI and 90,000 for your type 2, which just means that it takes 90,000 PSI to pull on a bar typically and get it to break. So a mechanical coupler has to allow two pieces of bar to perform in that same method and not allow the two bars to pull apart in anything less than full tension. So all the DSC splices are good in both compression and tension. Compression obviously is the force pushing on the bars. Tension is the force pulling on the bars. And so once that splice has been completed, the forces then are transferred through the rebar that's mechanically spliced rather than through any other method. So one note to be on the lookout for as you are considering Dayton Superior versus anybody else on the market is several of our competitor splices can only take tension or compression. They're not qualified for both. They're not approved for both. Again, all DSC mechanical splices are approved for both tension and compression. So walking through some of the final definitions here and just technical information before we get to the DBI is just some general information for you of what is yield strength. It's the stress to which a reinforcing bar can have a load applied to it and will stretch. Once the load is removed, will return to its original length. It's designated by FY, and once it's reached its yield point, it's been elongated or stretched and will never return to its original length. So you'll see what they call necking, which is rebar that has been stretched out and no longer looks like rebar. It's got a concave portion to it. That's all of the technical stuff. That's all of the humdrum, boring stuff. Now we get to the exciting stuff of the DBDI system. And the DBDI system is our parallel thread system. I would say it's our flagship parallel system. I love this system and the way that we put it together. It's two pieces. The biggest thing that I tell people is that second part, that it is upsized and hot forged. So everything you see here in these pictures and in these diagrams, these are all one piece of bar. So the male system, the male side is heated and upsized, and then the thread is cut into it. Same with the female. That flange is not welded on, it's not tacked on, it's not screwed on or anything like that. It is one piece of bar that is heated up. The end is formed into the flange, and then it is tapped for whatever size rebar it needs. This does, because of that upsizing process, because we take the time to do that, it does provide a type 2 splice for grade 60 on all sizes 4 through 11. So there's never a question of, are you getting the full capacity of the bar? Are you getting the best mechanical splice for what you're trying to do? It is as strong as it can be and as strong as a mechanical splice can provide you in just a two-piece system. It's hand tight. That means that there are no tools required. So it's a great use for projects with quick moving parts, and you've got a lot of guys on the ground. Installers don't have to be trained. They don't have to have any special equipment. They don't have to know anything. You can just grab the guy that just walked onto the job site that day and tell him to start screwing these together. And as long as he gets them hand tight, he really can't screw it up. They're fully customizable. We'll walk through that here in a second, but that means that we can do a litany of things, from single-ended to double-ended to hooks to we've got a crazy Z-bar that happens down here in Texas all the time that my customer service people love to encounter, but it's got double bends in it and all kinds of things. And because of the natural flange that comes out of the forging process, this is perfect for a form saver application. One of the benefits of it, obviously, is it eliminates any of what you see here. It eliminates bars from protruding out of a wall. Those are a safety hazard. They are punching holes through forms. There's all kinds of issues that come along with bars sticking out of a wall. It eliminates bars from protruding out of the slab. You can see there in that middle photo, somebody very nicely, very kindly ran over those bars to make it great as the installers come back and try to put that back together and figure out how they're going to make the column that's supposed to be standing there do what it's supposed to do. Instead, you could have the picture there on the right with mechanical splices embedded, flush in the concrete surface. People can walk over it. People can drive over it. There's no safety hazards on your job site. Your safety inspector is going to love it. And it's really easy to then, when you're on to the next phase, you just pop in the male bars and you're good to go. So to that point, what does the installation process look like? It looks just like this. Your female side goes into the forms, you nail it to the forms, screw it to the forms. For your first pour, whatever that is, whether in this case it's a horizontal flat pour, or if you have a vertical pour, whatever you need to do, your female end is held secure by the forms. Once that pour has dried, you then pop the forms off and you have an exposed opening for the male bar then to be screwed in. Again, hand tight, 5 foot-pounds, nothing more needed. And you have your connection point to get to your next pour and have that go as quickly as you need it to go. So I mentioned earlier, these are fully customizable. What exactly does that mean? It means that you can do whatever you want with it. So these are examples of hooked bars. This is a simple 90-degree hook bar, but as you can see on the order form there on the right, we can do 180 hooks, we can do males, we can do females, we can do double male end, double female end, we can do it with end anchors, we can do it with bolts, we can do it with anything, almost anything that you can think of. I've had people throw a lot of stuff at us and we've been able to do it. So there's not really any question there. One of the more popular things that we see is a single-ended headed bar. So this happens to be our bolt head version, which is used frequently in nuclear power plant applications. You can do that on a male or a female. We also have a end anchor version of it with just a regular end anchor on that. We'll get to that in just a second. But again, fully customizable. The D104A on the right there actually just had a project where engineer sent me his plans, had a whole bunch of congestion going on. He was trying to figure out how to put basically in a 3-foot cavity with number 11 bars. He was trying to figure out how to get the bar and a bar lock and another bar lock and all kinds of stuff that just screamed congestion to me. And when we looked at what he was doing and how he was connecting it to, the easiest and best solution was to put D104A double-ended splicers in the cavity that he had, let that be poured, and then he could come back with males on the other side. And it allowed for his project to streamline not only in installation speed, but streamline in how much congestion he was able to reduce. So never hesitate to reach out and say, hey, we're running into an issue, we've got a question, can you guys help us try to figure this out? I always make the joke when I'm making presentations, I may not be an engineer, but I've been around enough of them for the last 15 years that I can speak the language and I can usually help. And then you've got guys like Sean that are on the call that can talk a lot more engineer. So straight splicers, these are our bread and butter. These go out every single day across the country and across Canada. Our D101 and our D10A, all of the female splices have this integral flange that is just a natural part of the forging process. We can also do it with a clipped flange if you need that to hit some clearance specifications, but these are just easy to roll off the line in standard lengths, 18, 24, 36, 48, and they can be done up to, our handbook says they can be done up to 40 feet. I'm going to tell you all the conversations that I've had. They don't like to do them over about 35 feet, but I've gotten them to do them longer. So most of the time you don't need that, but you can get these in pretty good lengths as you need. End anchors, as I mentioned, these eliminate the need for a hooked bar. They reduce engineering design time. Again, all of this is a forged system. None of this is welded. None of this is screwed on in any way. The same process that we do for upsizing the male end and for forging and forming the female end is how we do these end anchors. So we heat the end of the bar and then compress it into what you see here as a forged end anchor. One of the great things about these is as opposed to a 90-degree hook, these will give you 100% of the tensile strength of the bar. So what does that mean? It means typically what you're going to see is when you get to the edge of a pour or the bottom of a pour or even the top of a pour, you've got a 90-degree hook going somewhere from the rebar that's in the pour that's in your build. If there are tension forces applied to that rebar with a 90-degree hook, you're only getting about 60% of the tensile. I'm going to learn how to talk today. You're only getting about 60% of the tension strength of the bar from a 90-degree hook. If you eliminate that hook, not only are you eliminating congestion, but if you eliminate that hook and replace it with a end anchor, such as you see here, you get 100% of the tensile strength of the bar. So not only are you improving the quality of your build by improving the strength and reducing congestion, you're giving yourself more security for how your build is going to perform. So the standard head size on these is 10 times the cross section of the bar, meets or exceeds ASTM A970. Again, if you have any questions about code compliance or questions about any of that, you can reach out to myself or any of the other TSRs and we'll help you with that. Also improve safety related issues. You don't have protruding rebar, you don't have hooks everywhere, anything like that. This is just some photos to show you exactly what we're looking at when we talk about that heating and upsized process, the forging process, some of the customizations that we can do. You can see there in the center, those are double females that are for either a ladder application or they're just for needing multiple bars connected in a close succession. We can do those with you double females, all kinds of options available to you with the system. And so we're going to finish out by letting Chuck step in. This is a project that he worked on with a wastewater treatment plant contractor, and he's going to take us out to the end to talk through some of the resources and talk through this project. But here you can see it live and in action, what it looks like. So hopefully that's been informational for you guys. Hopefully you guys have picked up on something. Again, if you have any questions, put them in the chat. We'll be happy to answer them at the end, or if you have anything that you want to reach out by email, you can definitely reach out to our technical team and we will help you in any way, shape, or form that we can. Appreciate you guys.
Okay, thank you, Matt. Okay, with this photo here, this just basically shows the application of the dowel bar, where it can be used, and how it can actually work for your contractor to save money. This contractor in particular actually gang formed all the walls on this with steel ply, and in lieu of putting all of these corbels off to the side, basically having the punch outs where his forms would be, he actually was able to actually install the rebar to this form, not have to worry about it changing his forms whatsoever. So his forms could be jumped from one system, one area to the other. And then he came back in and made the connection with the rebar, with the male section of the rebar into the female that was cast in the concrete, and formed it up and poured it. It's for a digester, this is a great systems to use. You see a lot of these products being used on wastewater treatment plants and parking structures. So what we have for resources here, we've got obviously on our website at DaytonSuperior.com, all of the product pages for all the products that we've talked about here today that Matt alluded to, with dowel bar D101s, the D108s, the D101A, etc. So all of these are readily available, along with tech data sheets. We also have a handbook that's also real handy to come by. You can actually download this off of DaytonSuperior.com. As is the order form. Actually helps if you've got projects here that you're working on. This actually enables, especially that there's no confusion between customer service and the estimator, what they're actually looking for. The DBDI form is available off of our website, as is any of our certifications and certification reports and AMPO certificates that may be required. How do you get a hold of, Matt referred to call him or call any of the other technical service reps. If you look on our website, we actually have interactive maps here depending on your region of the country. You can actually click on it and contact, you'll see what part of the country, who your splicing representative is, whether it be Mike Best out on the West Coast, Matt here in the Central region. We've got Sam Connolly up in the North on the East Coast. And so these guys are all here primarily just for splicing products. So we also have all of our compliance letters. A lot of our letters that have to be required if we need to have specific letters written for the job site. We can actually produce those up here and have letters, as long as we can meet the specification, we can actually supply you with the certification letter for it. Now, we got a few minutes. We went a little bit overhead, but we get some time for questions and answers. If you are looking for additional training, please scan the code down, the QIR code down at the bottom. That will actually direct you to training at DaytonSuperior.com. You'll have a form that you can fill out there requesting training. And when it comes into Heidi and myself, and what we will do is we will pass that along or handle it ourselves as far as if anybody is looking for training. Okay. So if you have any questions, put it in the chat functionality. And we'll give you a couple of minutes here. If not, like I said, I'd like to thank Matt again for taking time out here to help us out with this training. And I'm not seeing any questions coming in. So with that, I'm going to say thank you very much. And everybody, please have a superior day and stay well. Take care now.
Thanks, guys.